are at the Trimble booth with this luxurious BMW car, but we are not talking about the car here and we are not the experts, but we are here to talk about the Trimble MX7 mobile mapping solution with the expert Marco.
Hello, my name is Marco Belo. I'm a Trimble employee. I'm looking after the mobile mapping portfolio for the EMEA region. And what we're talking today is about the Trimble MX7. So the idea with the MX7 was to have a kind of entry-level mobile mapping system, if you like. The Trimble MX7, as a matter of fact, is an imaging solution. It's a mobile mapping unit which is capable to collect pictures, and we wanted to have a product easy to operate, easy to deploy, with the data collection software easy to be operated not only by specialists of the mobile mapping world. So this was the main concept we have when we decided to develop the Trimble MX7. So the key elements of the Trimble MX7 is that we are combining a 360 degrees camera together with an inertial or NS platform, which is embedded inside the unit, where we have gyroscopes, we have accelerometers. The system can be combined as an optional with a DMI or distance measurement instrument or encoder, wheel encoder if you like, and together with GNSS. All these sensors are at the very end providing the positioning of the vehicle or the position of the camera from which we later on need to extract information. So the camera we have embedded in the system is a point array camera, is a Ladybug 5, is a 30 megapixel unit with which we are able to collect pictures, and the software is stitching imagery together so that at the very end the result is that the user can see a panoramic view, a spherical view of the environment, can rotate and can collect pictures. We have 6 CCD sensors in this camera, 5 looking on a horizontal ring and 1 on the top, in case we need to do some inspection of the top of the bottom of some tunnels or bridges. The positioning, the satellite position technologies we have is a full GNSS, which means that we can benefit not only from GPS but multiple GNSS constellation to achieve better positioning informations. The idea, as I said before, was to have a clean system from a software standpoint but also from an hardware standpoint. This is why the only 2 cables which we need to provide, which we need to connect to the system, is a power cable. Power is coming from the battery of the car or the vehicle, which is used to operate the MX7, and the other cable is the data cable. The data cable is connected to a Wi-Fi access point, which means that with a tablet, with a laptop, or whatever kind of PC with a Wi-Fi technology embedded, we can connect to it and operate it remotely using a standard internet browser. Into the system we have a storage capacity of 1 terabyte, which allows us to collect data for around 10 days of operations, dependent on the triggering distance of the pictures which are collecting the system, which of course is a parameter that the operator can define in the settings. As we said, the idea was to have a field software easy to operate, and this is the tablet solution which we use to operate the system. Basically very few settings, which we just need to tell to the system which is the height of the camera and which is the triggering system for the pictures, and then we simply have a start recording and stop recording to start collecting pictures and stop collecting pictures. We have information for the operator about the navigational status, meaning we have good GNSS coverage, or sufficient GNSS coverage, meaning we have good GNSS and IMU information coming to the system. On the web interface, we have on the user interface, we have 3 commands. 1 command to start the mission, meaning the data collection. 1 command to button to download the data from an internal memory. And 1 command to set some settings. As I said before, settings could be the height of the camera, and settings could be the triggering distance of the camera. To start operating the system, you just need to click on Mission. You need to apply the setting you specified previously, then just click an Next command and start the mission. Starting the mission, the unit will start recording the positioning informations like GNSS and all the IMU stuff. And then the navigational bar will switch to green, which means that we will be ready to start collecting camera information. We are in the mission now. We are uploading the camera informations, and then again, navigation status now is red because no GNSS information is coming into the system, of course, because we are in a closed environment. We have a navigation tab where we can check the performances of the system in terms of accuracy, noise, and height performances. We can check the GNSS constellation, PDOP values.
What is the on the button for?
Sorry?
What is the auto button for?
With the auto command, we can basically change the settings of the image, like the brightness and the contrast of the images. Auto means that the system is adjusting these parameters on its own. As soon as the mission is accomplished, and as soon as we have downloaded the data with an external drive from the USB port of the unit, there are two steps we need to do. The first one is we need to process the trajectory of the vehicle, because we need to have good coordinates to be applied to the camera. To do that, we are using our software, which is called PostPack. What we are doing is we are importing all the navigational information from the system, means INS and GNSS, and we are downloading RANX files from cross-reference stations. Or we could even use virtual RANX files, for example. And this is the software PostPack with which we process the trajectory. The final result of a trajectory processing is basically a kind of polyline, which contains the correct or accurate position. And these files need to be applied to the sensors. In this case, the sensor is the camera, so later on we need to apply the trajectory to the camera. And the way we do that is using Trident, which is the other software which comes together with the system. With Trident, basically, we are applying trajectory to the camera and we are starting extracting information from the images. So what is the data extraction from the MX7? Let's assume that you are a company and your task is maintain, for example, road signs. Usually this is a mainly kind of GIS task. So the first thing, you need to create a database or a layer, if you like, which will contain all the road sign information. If you already have some already existing, for example, shape schemas coming from already existing database, you could import this schema as well and make use of these schemas into Trident to start exporting information. Or maybe if you already have some ODBC structure or already existing database, you could link directly to already existing databases to populate with the fresh new information coming from the MX7 system. Let's assume we are starting from the scratch now, meaning we don't have any database, any layer, so you can create it by yourself. You can create layers specific to features and all the attributes related to these features. In this case, we have in Trident, we have just created a layer which is called a road sign, and we will make use of this to extract the road sign information. For example, let's assume that I am extracting road signs from this street, and this could be an example of an object which we need to extract, and we have the layer ready for that. We could select the road sign layer, we could select the extraction tool, and in this case we are using a kind of terrestrial photogrammetric approach, meaning that we are selecting or clicking on this road sign from two different pictures. As we have the coordinates of the camera positions, then we can intersect and extract the position, the coordinates of this object. This is what we are doing now. So with one click, with a second click on the object, basically we have the coordinates now in our database. And for example, what we could document according to the layer we created is which is the condition of this road sign. Could be a code, like for example, 2 could mean, for example, need maintenance, for example. Additionally, we can import a road sign library, for example, like this one, and we could just select the icon of our road sign, which is this one in our example. We could also specify, for example, who is the company in charge to do the maintenance of this road sign. For example, could be company B. And to additional document the condition of this road sign, we could also take a snapshot of the road sign, just dragging a rectangle around the object. We can apply this, we can basically save it, and all this information is at the end stored in the table of our database. Here we have all the information of all our road signs we just collected. And the very last step, as soon as we finish the data collection, consists in basically selecting our layer and extracting or exporting in the format we like. For example, we could interface directly with ArcMap in two different ways, for instance, shape 2D files, 3D height if you want information as well, or could be the database file only. And the thing is that when we extract as a shape file, of course then in ArcMap, for example, we can create the link with a folder containing the images which we extracted and the icons we have been using in order to populate nice thematic map also in ArcMap. Now we accomplished the first task, which could have been create the database of our road sign. But the work is not finished because probably I will need to maintain or keep this system alive, maintain the information in the database. To do that, of course, we could still make use of the MX7 to collect again runs on the same streets, or the project manager from the office could create some tasks, like activity to be fulfilled in the field. For example, if this road sign has been damaged because there was a construction site, for example, the project manager could verify from the MX7 dataset that there was an issue on that road sign because of construction site, for example. Then the project manager from the office can create a task. For example, operator A, you need to go out in the field and check again the position and the condition of that road sign. In this case, the operator is sending a shape schema which we can upload into our GIS solution Terraflex, and the operator with Terraflex can go out in the field at the same road sign, take pictures, fill tables, basically using the same shape schema which was created with the data collection from the land mobile mapping system. As soon as the operator in the field has finished the upgrade of the information, the fresh new condition of the road sign, then the operator can click a sync command on Terraflex, and then the new information are just synchronized back to the office. So this makes a complete straightforward workflow for road sign maintenance, for example.